Assalamualaikum warahmatullahi wabarakatuh. So we are from group 2, and on this video we will cover the step-by-step how to get first frequency analysis, reliability test, ANOVA, t-test, correlation and regression. So just enjoy it. In this video I will show how to transform questionnaire data and create a new variable in SPSS. First, we open the SPSS right here, and first go to the top menu and click transform, then choose compute variable. This transform compute variable, then at the target variable. For example, at the target variable box, type the name of new variable. Like for example, like me, I will choose a total aesthetic. Then at the number expression, type your formula. For instance, if you combine equation 1, question 2 and question 3, so choose the question 1 for aesthetic here, plus aesthetic 2 plus aesthetic 3 plus aesthetic 4, and here click OK. So right here we get a new data for total aesthetic. Then that's how to get a total for aesthetic score. But how to get a average for statistic score? Same, go to transform compute variable, and then we just need to add a bracket here. This is very important here. The bracket is very important. So open bracket and close bracket. Then we need to divide 4 because we have 4 questions here. Then we click OK. So then that's all. So we get a new data for average for total aesthetic. After that, with this new data, you can now use this variable in analysis like ANOVA and correlation, and that's how you transform the questionnaire into a new data set in SPSS. That's all from me. Thank you.
Now we want to try to do a frequency analysis. So when we want to do a frequency analysis, we go here, up here, which is analyze. Then you go to descriptive statistic, then find frequencies. You go to here and find what you want to set the frequencies to see what are the frequency that it can give to you. So here I can take gender and I go to variable. So go to statistic and set the thing that you want to see in the process. So go to continue, and then you press OK. And then you can see here the respondent all have here, which is 267 and none is missing. So you can see what is mean and median. And below here in the table you can see the frequency of the male and female, which is male is 67 and female is 200, making the total of the respondent is 267, same as up here as the n value, which is the respondent. So the percent here is the system also give it to you, which is the male is 25.1% and the female is 74.9%. And here it is the frequency of the gender. So next, the frequency is especially for the continuous variables such as age and gender. It cannot go with the variables such as independent variable and dependent variable. To do analysis, frequency analysis for the independent and dependent variable, you need to go to also analyze, go to descriptive statistic also, but you go to descriptives. Okay, you go to descriptive, you find the variables that you want to process. Here I take 3, which is total intent, total attract, and also total aesthetic. Go to options, click mean, standard deviation, minimum maximum, on also kurtosis skewness, and then continue, and then you go OK. Here it will give to you all the descriptive information about the variables that you put, which is here it put the total of the respondent and which is 267 for all the variables. Here it also show the minimum answer of the respondent give to you, which is 1 for the all of these variables, and maximum, which is 5, the max, the mean, which is the statistic of the mean of the answer of the responder that give to you, which is for the total intent it give 4. Total attract is give 4 also, which we round out, and also total aesthetic also 4. Standard deviation statistic all shows that it is below 1, which is it shows that it is reliable because it is closely range of the answer. If it goes up of 1, up above 1, it will shows that the data and the answer of the respondent is widely ranged, which is it not too reliable to go with the answers. And next, cuteness and cortosis. To find the Z point of the skewness and cortosis, you need to go to statistic and divide it by standard error. You divide it. If you got it below 2, it is acceptable. If the total calculation go up of 2, above of 2, it will go. It will not be accepted by the system. So next we go to analyze. We go to descriptive statistic. Also, and then we go to explore. Here we go to explore, we can pick the variables that we want to pick. So I pick total attract here. So we go to statistic, tick descriptive outliers, then continues, go to plots. Here untick stand and leave, pick histogram, and tick the normality plot with test, and then continue display. We pick both, and then we go to okay. Then it will go, data will go out like this. So it shows you the total respondent that you get, which is 267, which is what is valid, what is missing, and the total. So here is no missing respondent that is recorded. And then we can see the descriptive, the extra value, and here the test of normality. Here we can see that total attract the normality of the Kolmogorov and Smirnov, which is 0.00, Shapiro-Wilk also 0.00. Which is, it says that if the it goes below 0.5, it basically it tells that it is different from normal distribution. So basically it is negatively skewed. It rejects the assumption. It is happened to the two of these test of normality, which is the Kolmogorov, Smirnov, also for Shapiro-Wilk for this variable total attract. And then we can see the graph, the plot of total attract and the histogram. We can see that it goes more to the right than it goes to the left. And here we can see the plot of total attract. You can see that it is not equal to 0, which is the point is right on the line. So it shows that the data, it is not too varied to what we want in the answers, but it is normal for the social science research because we cannot control the environment. So here we can also see the box graph, which is it shows the range of our data. So all the answers are varied in this range of data, so we can see at the range of this box, but there are two respondents, which is responder 121 and one responder 162, which is too far away from the range of the answer that we want. So for this respondent, we can choose to fix and to fix or clear them. So we can go to the respondent of 121 here, as you can see. So we can right click and clear, and also we can fix the data. So by that we can make the range of data will go back to normal and go to the plot that we want. So after we do the frequency analysis, now we want to do a reliability test, which is we can go here at the tab analyze, and we go down to scale, and we can find reliability analysis. We click and we can pick the variable that we want, which is here I can take total intent, total attract, and total aesthetic. We can put them into the items that we want, the variable that we want. So go to statistic, take the item scale, and scale if item deleted. The inter item, tick the correlation. And here you can continue. Make sure the model is alpha, and then you can press OK. Here we can see the results of the reliability test, which is here we can see the Chromebook alpha of the statistics. If we go down below here, the item total statistic, we can see the Chromebook alpha for all the variable that we pick, which is total intent. Here we got 0.783, total attract 0.645, and total aesthetic is 0.657, which is for the alpha coefficient range. If it's below 0.5, it is poor. If it's 0.5 to below 0.7, it is moderate. If it is 0.7 until below 0.9, it is high, and it is above 0.9, it is excellent. So here we can see that total intent, it is high in reliability. For total attract and total aesthetic, it is moderate because it is between 0.5 and 0.7.
Okay, next we move to ANOVA. So we go to the analyze, then we click a compare means, and we choose one way ANOVA. So at the dependent list, we will take a new data that we get just now, which is the total aesthetic, this one, and at the factor, we will take a number of visit, this, and we will put at the factor. Then at the post hop, I will take a 2 key, continue, and the option button, choose descriptive homogeneity of variant test, brown frosty wedge mean float, and continue. Then we click OK. So this is the result of ANOVA test. Then we scroll down and look at the ANOVA result of the total aesthetic. So and then we look at the first line of significant column. This one is 0.954. As we just can see, this result is higher than 0.05, which means there is no significant difference in aesthetic score among visitors who come for the first time and fifth time and above. So this means that visitor frequency don't really influence how they perceive the aesthetic of the place. So in conclusion, all groups have roughly similar views and aesthetic verbal. So that's all how to find the ANOVA result. Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Faiz. Metric number 077441, and today I'm going to show how to find a t-test result. Okay, first thing first, we click on analyze at the top and choose a compare means. Then at the compare means, we take a independent sample t-test. Then we reset it. Then at the test variable, I will choose a aesthetic one and put at this, and at grouping variable I will choose a gender and put at the grouping variable. Then this is very important, we need to define the group. So the group 1 I will choose a number 1 as a male, and group 2 I will choose number 2 as a female. Then we click OK, and this are the result of the t-test. So after get this result, we look at the significant column at the Levin test for equality and variance, this one, and we look at the first line. So at here, the significant number is 0.113, which means it's a greater or higher than 0.05. So the variance are same, and at the first line we call it equal variance SUHAIMI. So not just that, after that we look at the significant two-tailed, this one at the first line. So this is a 0.817. So this is the result, which is 0.817. Since 0.817 is higher or greater than 0.05, it means that no significant difference between male and female. So in conclusion, based on the data, male and female have roughly the same level of aesthetic when with notable difference statistically. So that's all how to find a t-test result.
Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad SYIMIR. So for my part, I will explain about the hypothesis testing, and we use two technique, which is correlation and also regression. So for the correlation, for your information, to test whether there is a linear relationship between two continuous variable here. So let's do that. The first, we go to the analyze, and then we go to the correlate and pick the first one, bivariate. So there is, you need to fill in the variable 2 or more, and then at the correlation coefficients, you need to pick the person here, and test of significant to tail and flag significant correlation is need to be ticked also. And then we go to the options. Here at the missing value, you need to tick the exclude cases pairwise. All right, so continue, and then okay. So this is the result. So at the first look, we need to identify the n, which indicate as number of cases. So here, the n here, you can see there is 267 respondent, and also for the total answer also the same here. So it's a good one because there is no any missing respondent. And then we try to determine the direction of the relationship. Here, as you can see at the person correlation 0.495, there is no negative. Also at the total attract, there is no negative here. It means it's really positive. Also, it's also mean that the more attractive the destination, the high people intention to travel. Okay. And then for the next one, we will determine about the strength of the relationship, which based on the Cohen guideline. So the value is there is 0.495, indicate a medium large correlation between the two variables. So suggesting a quite solid relationship between total attract and total intent. So how to calculate a coefficient of determination? So you need to multiply the R value. The R value is a person correlation here. So the 0.495 is the R value. So you need to multiply by 2, and then you multiply it again by 100 to get percentage of variance, like this one here. So this is the result, which is 24.5%, which is quite good and moderately good. Okay. Now the last is the significant level. As you can see here, the significant is 000. So this shows the correlation of 0.59295 here is significant statistically. So this is not coincidence in sample, but probably exists in the larger population. So this is for the correlation. Now let's go to the regression. Alright, so right now we go to the regression, and for the information, regression is to test whether one or more independent variables significantly predict a dependent variable. So for this time, I will show you how to do a multiple. Okay, so the first one, we need to go to the analyze, and then go to the regression and choose linear. Okay, so here this is the phase of the linear regression. You need to fill in the dependent and also the independent. So for dependent variable, I choose total intent, and independent, I choose total aesthetic and also total attract. And then we go to the statistic, and here you need to take the estimate, confidence interval, model fit, descriptive, part and partial correlations, and collinearity diagnostic. Okay, and the residual is case-wise diagnostic, also outliers outside, and 3 standard deviation. So continue, and then we go to the options. At the you need to include the constant in equation, and missing value you need to take the exclude case pairwise. Okay, and continue, and then we go to the plots, and here you need to fill the ZRESID in Y box, and also ZPRED in X box. And the standardized residual plots, you need to choose normal probability plot. Okay, continue, and then okay. So this is the result, and as we can see here, so first let's examine the assumption multicollinearity. Okay, so first let's see at the correlation. And for your information, the IV must less than 0.7. As you can see here, the total aesthetics is total aesthetic here is 0.643 and 0.495. So it's good actually. It's good for the aesthetic, 6.543 and 4.79. So it's not exceed 0.7. So it's good. And then we go to the coefficients table. So this is where we examine the multicollinearity existence. We're looking at the tolerance and VIF. So first, let's go to the coefficients. This one. And this is the tolerance and VIF. So these two has inverse relation. At tolerance, show 0.5x9, which not less than 0.1. And it indicate no multicollinearity. And at VIF also, it should not exceed 10, as the table show 1.705. So it's good result actually. So there is also no multicollinearity at all. And the next one, let's go to the scatter plot. Okay, this scatter plot is show it that the benchmark can't exceed the 3.3 and no less than 3.3. So based on this scatter plot, we identify about 3 outliers, which is this one, the outliers, this one, and this one. So it's 3 because these 3 have been exceed 3.3 and also less than 3.3. However, the residual must roughly looks like the rectangle shape here, the rectangle shape, and it's also close to the 0. This is the 0, so it's around this place. Okay, so as we just find a few outliers, which is 3, so we are not taking any action. Okay, so now we will want to see how far the IV influence the DV. We go to the model summary. All right, so this is the model summary. Yeah, this one, the model summary. So we look at the R square, which is 0.289. Now we convert it to the percentage, which is multiplied by 100. So it's equal to 28.9%. And it explained that 28.99% of the variance in travel intention. So we don't use adjust R square because our respondent about 267, which is not less than 100. So it's good to use R square rather than use adjust R square. Okay, next is we go to the chart here, and this is show the most significant as the dots really close to the straight line. And the last one is ANOVA. Okay, let's go to the ANOVA. Which one is ANOVA? This one is ANOVA. Okay, so to assess the statistical of the result, the significant table must below 0.05. So it's considered significant. So as you can see, the result is show that the significant is 0, 0, 0. So it's really significant. And now for evaluating the IV, we look at the coefficients. Here, coefficient here, which is the mark of the standardized coefficients here. So we looked at to analyze which one have the more impact to dependent variable. As a result, total attract makes the strongest unit. Here, total attract makes the strongest unit, which is 0.318. And the beta of total aesthetic is slightly lower, which is 0.275. And both IV is significant as show 0, 0, 0 here, which is made unique and contribution to predictor of intention. So that's all from us. Assalamualaikum warahmatullahi ta'ala wabarakatuh.